Hi, my name is Rupesh More, and today I will demonstrate the final project for my cloud computing course um, at Harvard. The project name is Cloudera Impala with the R integration. So basically, this will be done by the Amazon Elastic Map reuse. That is the um, Elastic Map reduce cluster will be started, which has the pre-installed Hadoop, Hive, Impala, and R installed. We'll start that cluster. So the agenda for the presentation is what is Cloudera Impala, what is Hive, then the differences of Impala from relational databases and Hive, then what is R and what is RStudio. Sorry, the Amazon EC2 cluster with pre-installed Hadoop, Hive, and Impala, the installation of that, and loading sample test data in HDFS format on that EC2 master instance. The writing SQL queries and executing it against the data loaded in Impala and Hive. Then optimizing queries in Impala, configuring Cloudera Impala ODBC drivers, analyzing Hadoop dataset with R and Impala, and finally plotting the Impala dataset as a graph on RStudio for analytics. So, what is Cloudera Impala? It is an open source tool in Hadoop ecosystem for interactive and ad hoc querying using SQL syntax. So basically, it's faster than Hive. It can query data in HDFS or edge-based tables, and also it does analysis in real time, and also it does not use the map reduce. That is why it is faster. Now let us see the architecture of Cloudera Impala. This is the architecture. So the Impala consists of the following components: the client, which includes ODBC clients and JDBC clients, and the Impala-shell, which can interact with Impala. Um, then the Hive meta store, which stores information about the data available to Impala. Then the Cloudera Impala, this process which runs on the data nodes, coordinates and executes the queries. Then the HBase and HDFS, which is the storage for the data to be queried. The next agenda of the presentation is what is Hive. So basically, it's an open source data warehouse and analytic package that runs on top of Hadoop. It enables you to avoid complexities of writing MapReduce programs. It uses an SQL-like language called Hive query language that abstracts a MapReduce programming model and supports the data warehouse interactions. Now, these are a few of the differences between the RDBMS system and Impala. And the second table shows the differences between Hive and Impala. So basically, just go through the differences. Next, we'll see what is R and RStudio. So basically, R is a programming language, and it is used for statistical computing and for graphics. It's basically an analytical tool, which is similar to S and MATLAB. MATLAB is basically is a licensed software, so you have to pay for it. Whereas R is an open source tool. And the RStudio is basically a convenient user interface to R. Um, Next, we'll see the requirement to run Impala on Amazon Elastic MapReduce. Basically, we require an AMI, which is an Amazon a machine instance, which has pre-installed Hadoop, having version 2.x or greater. Then we will require a Red Hat or later the Hadoop 2.x, Hive, Impala 1.2, R and RStudio. Now let's make an Amazon Elastic MapReduce cluster. Now this is the master node of the Elastic MapReduce cluster. So to create an Elastic MapReduce cluster, you have to log into Amazon AWS, go to services, Elastic MapReduce. Now this is the cluster that is already running, which is having an Impala. So to create a new cluster, you can click on Create Cluster, give the name of the cluster. For login, give any S3 bucket. um, for Hadoop distribution Amazon. Select the latest EMI version, which is 3.0.2, for which you will be having um, Impala. See, the lower version do not have Impala. Like if you select 2.4.2, you don't have. Select this Hive, Pig. These are the applications that will be present in the cluster. For the master node, there is one master, whereas the slave AMM machines will be two. You can select the availability zone. You can, if you have a security key, you can select the security key. This is the public security key. Um, Bootstrap action is not required. Then you can click on create cluster. Now let us see the already running cluster. Click on it. You will see the status as waiting. Here are the details of the cluster. The master public DNS name is as shown here. Other things are not important. Go to EC2 instance. Mm, there are basically 4 running instances. Select the instance type as running instances. Now, basically, these 3 instances are the one associated with the cluster. Select the master, search for the master EMI instance. This is the master. You can see the select security group as master. Um, this is the slave, first slave and the second slave. Now to connect to the master instance using SSH, you need to have a public a DNS name. You can select the connect. This is the command to connect to the master instance. Instead of root, we need to connect via the Hadoop user. Let's connect to the master instance using terminal. This is my terminal connection. This is the key, Amazon key. I have over here. This is the command um, for which I'll be connected to the master instance. You can see which uh, where Hadoop is installed, where R is installed, where Impala is installed, where Hive is installed. You can connect to the Impala-shell by typing Impala-shell. So this is basically the private IP of the master instance, whereas this is the port, uh, default local port of my Impala instance. Now let us load the data into HDFS format. Here, um, here loading the sample test data in HDFS, like in I have already loaded in the master instance the data for books, customers, and transactions. So let's go to this instance. Quit. Mm. The data is taken from one of the websites. Basically, this files in HDFS format are of 1 GB, 1 GB. So let us see the data in the few of the rows in the transaction tables. So the command is like, I'm selecting the 5 rows starting from the head, as in so 0, 1, 2, 3, 4. In total 5 rows from the transaction table. Sorry, from the transactions HDFS file. Let us go to the next slide. Creating tables in Impala-shell. So basically, these are the after connecting to the Impala-shell. Here we have three create statements, create table statements, books, customers, and the transaction tables. These are the columns um, of that particular table, which is delimited by a slash, whereas the data is located in this location, the data slash sorry the data slash books for the books table for the customers. This is the location. So basically this is the command. So after this command is executed, we will have that data stored in the form of tables. Now let us fire some queries um, on this particular tables, the books, customers, and transaction tables. Um, so this is one of the query. Let's connect to Impala-shell. So fire this query. You can see that the customers table have uh, the count of the customer with the name Madeline Hernandez has 342, like in 342 rows are present with that particular name. You can also see that the uh, query is returned in 1.51 seconds, and also since we are running this query in Impala, there's no map reduce job that runs in the backend. So this is the first query. The second query is an aggregation query that scans a single table group of rows and calculates the size of each group. Let's fire this query in Impala. So go there. Let's fire this query. So you can see that 10 rows are returned because we are giving a limit of 10 in just 2.29 seconds. Similarly, if you fire the third query, which is query that joins the book tables with a transaction table to determine the top 10 book categories that have maximum total revenue between these years 2007 and 2009. So if you fire this query, the time taken is just 23.97 seconds. Um, then the fourth query is a memory intensive query that joins all the three tables. Here the time taken is 59.39 seconds. Now let's run this four queries in Hive. So basically, when we run the same query uh, on Hive, the first query, which is the um, count on the customers table for the name Madeline Hernandez. The time taken is 68.908 seconds. This is because uh, and in the back end, the number of map reduce jobs that run takes a lot of time. Whereas in case of Impala, it since it directly runs on HDFS, we save time uh, in Impala. Let's go to the terminal, script from here, connect to Hive. Yeah, here we have the Hive prompt. Let's run the query. So here you can see that um, the total number of map reduced jobs equal to 1. So now it is starting the map reduced job. See here, the stage 1, the number of mappers is 5 and the number of reducers is 1. The same query in Hive takes a lot of time. See, the map reducer job got completed. It returned the number of rows. It equal to 342. The time taken is 60 seconds. If you compare that with Impala, the time taken with Impala is just 1.51 seconds. So basically, Impala is very much fast. Now let's see for the other three queries on Hive. This is for query 1, this is for query 2. The time taken is 68 seconds. For query 3, it is 252 seconds. And for the resource intensive query 4, it's 895 seconds, which is in turn a very lot of time, very much time. Here you can see the number of map reduced job is 6. Um, for job 0 mapper, 10 mappers reduce 3. So basically a lot of map reduced jobs were involved in the resource intensive query, um, which was very time consuming. Let's go to the next slide. It's optimizing queries in Impala. So basically, Impala does not load entire tables into memory. It builds hash tables in memory, such as a right-hand side table of a join or a result set of an aggregation. Impala uses memory as IO buffers. So in order to avoid out-of-memory errors, it's important to optimize the query. And the query optimization techniques is effective in allowing your queries to use less memory. So basically, this is one of the queries used here. The transactions table is to the left of join, whereas the books tables is to the right. When we run the query in Impala, it took 24.95 seconds, uh, whereas the optimized query, the previous one was a pre-optimized query. This query is optimized because here we have the books tables to the left and the transactions table to the right. When we run this query in Impala, it just took 14.95 seconds. Why is it so? Because we can see that in the next slide. It's While performing the joins, Impala builds and hash table from the books table that contains only the category, price, and ID columns, whereas the transaction table is not cached. Since Impala broadcasts the right side of a table, uh, in in the first case, books table is replicated to all the nodes that are required for joining. The second version of the query is efficient because only a part of the transaction table is broadcast instead of an entire. Um, we can further optimize the query with hints which will force the query to use the partition join. Um, Now let's move further. Configuring the Cloudera Impala ODBC drivers. So basically, ODBC driver is required to be installed to connect for some of the well-known popular BI tools. Here we will integrate R with Impala 2. This is done because it provides fast interactive queries running on top of a Hadoop dataset, and then the dataset can be further processed or visualized within R. So the commands basically used on the master AMI is here this command sudo yum install R will install R. In my instance, it was already installed. That is why this message of nothing to do have appeared. Then install the EPEL package. So this is the command to run the package. Um, Next, to install RStudio package. First, we'll get the rstudio.rpm file from this link. Then we will try to install RPM package using this command. Here, everywhere we are using sudo because since uh, we are logged in as a Hadoop user, and only root has privileges, so we have to use sudo. Next, to install the dependent files. In the previous step, you can see here that the install of RStudio server was not proper because there was a dependency on these three files: um, libcrypto, fortran, and ssl .so.6. So we will install those files first. This is libcrypto.so.6. The second is to get the libfortran file. Once the dependency is resolved, then we will install. Then we again run the RStudio install command using yum, and this time the installation is successful. Once the installation of RStudio is complete, the default port is 8787. So we can see that on 8787 we have an R server which is already running. Let's move forward. The configuring Cloudera Impala ODBC drivers. To ensure Impala ODBC drivers will work and our ODBC package can be installed within R, we have to install some of the Unix ODBC packages, which is Unix ODBC and Unix ODBC hyphen d hyphen packages. This is the command for Unix ODBC. The second is Unix ODBC deal level. Once this is installed, we can then install our latest Cloudera Impala ODBC driver. The name of the driver is this .rpm from the Cloudera website. Um, so this is the command using yum. Uh, After this is installed, Cloudera ODBC driver is installed. We can then use the configuration file required to be modified. So the configuration files are odbc.ini and cloudera.impala odbc.ini. So you have to uh, put the file in the appropriate location in order to connect to R with Impala. In odbc.int file, you have to edit the host to localhost port to 121.050, and the default and the database should be default. Whereas in cloudera.impala odbc.ini, you have to just uncomment this line for the Simba dm / Unix ODBC. Below are the environment variables that you need to set up after installing the ODBC, after doing the setup for the Cloudera Impala ODBC drivers. So the three environment variables are ld underscore library underscore path, ODBC ini, and simbadn. Um, Next, we will see the install of our ODBC package for R. So once you connect to R, you can install the R ODBC packages within R. Now, next we will analyze the Hadoop dataset with R and Impala. Once we connect to R, so this is the connect string, the ODBC connect. So via this command we'll be able to connect to Impala, and from Impala we can run the select query. So basically this is the uh, query 4 that we had used previously. So once we run this query in Impala, we'll store the result in the result variable within R. So let's run it. Go to terminal, connect to R. This is the now we are connected to R. Let's connect to Impala. Sorry about that. That's an error. We need to first connect to the library ODBC. Then we can use that connect ODBC connect command. So let's connect to Impala. Um, Run the query and store the result in result set. This is since this is a resource intensive query, it's going to take some time to complete. The query is complete. Let us check the result. So these are the 50 rows that are returned by the query. Now let's plot the result retrieved on RStudio using its plot. So on the x-axis we'll have the book underscore category, whereas on the y-axis we will plot with the we will have revenue. So basically, so these are the commands used for plotting the graph. The plot command, the lines, and the axis. So let's go to the um, RStudio. So this is the DNS name wherein we have the RStudio installed. Uh, I have stored the results in a .csv format. Let us just read that CSV file. Um, the CSV file is stored on the local directory. Let's reload this. On the console, run CSV. Read CSV is stored now in the result. Let's plot the graph. So basically we have the graphs with dots. So on the x-axis we have the book category, whereas on the y-axis we have the revenue in USD. Let's have some lines and the final plot. So this is the plot that we have achieved. So basically what we conclude is that Cloudera Impala is exciting new technology to provide a real-time interactive queries in Hadoop environment. It supports ODBC connectors, which makes it possible to integrate with BI tools and statistical software such as R. Together, R and Impala provide a combination for data scientists to process massive data sets efficiently and also support graphical representation of result set. So that concludes this presentation. Thanks for watching the video.